All right, so what we're talking about today is section 1.4, which is complex numbers, sometimes known as imaginary numbers. I really don't like that term imaginary because it makes everybody think that they aren't actual real numbers and that they're like more confusing than they really need to be. But we have what is called the imaginary unit, which is defined by I, the lowercase letter I, and it equals the square root of -1. This also then implies to us that we've got, or equivalently, I squared equals -1. So if we come across one of those situations where you have to take the square root of a negative number, this kind of an idea will allow us to handle that. We are going to have complex numbers when we look at this, which is a number in standard form that looks like this, a plus bi. And then we are going to have, from there, we can have the imaginary part and the real part. The real part will be the a, the imaginary part will be the b that's in front of the I. Not bi, but just b. It's just like that coefficient in front of the I. So if we look at some of these here, it asks us to classify the parts of the following numbers. Basically, what's the real part, what's the imaginary part? So here, the real part is the -4. The imaginary part is going to be just the 6. For this next one, the real part is going to be 0, and the imaginary part is going to be 2. So take a moment real quick and see what you think are the real and imaginary parts for the very next one. So when we look at this one here now, we've got a real part of 3 and an imaginary part of 0. And basically what this means is, like, for number 2, we could have written this as 0 plus 2i, and for number 3, we could write that as 3 plus 0i. And so the idea is we can always write any complex number or any number in that standard form, a plus bi. So let's take a look at some operations with complex numbers. Here we're going to do some addition. We're going to add some complex numbers together. And essentially, you just basically add up the real numbers together and you add up the imaginary numbers together, and that's what you get. So we don't really even need these parentheses. It's going to be 5 minus 11i plus 7 plus 4i. So we don't have any negative to distribute through or anything. And then we're going to group it. 5 minus 7, and then we're minus 11i plus 4i. So 5 minus 7 is going to be not minus 7, 5 plus 7, sorry. 5 plus 7 is going to be 12. And then negative 11 plus 4 is going to be minus 7i, just like that. And then the next one, we have to distribute that negative sign. So we'll have negative 5 plus I, and we'll have minus negative 11, which becomes plus 11, and then minus negative 6i, which becomes plus 6i. And again, we can group the like ones together. Negative 5 plus 11 plus I plus 6i. Negative 5 plus 11 is just 6, and I plus 6i is 7i. All right, so it's just a matter of just grouping the terms that are the same together and adding them up. So what I'd like you to do is go ahead and try and work on some of these right here. And while you're doing that, I'm going to pause this. All right, so on some of these you should have been pretty good, but what I'm going to do is show you number 8 here real quick, and it also allow you to do number 7. So when you're multiplying them, we have to go back to using this definition pretty much right here. We're going to use that one. and it's just I, and so we're going to put it together. So when we have this, what we end up with is 4I times 3 minus 4I times 6I. So we end up with something like that, and I could even put this in parentheses. All right, and so when we do this, we actually go ahead and multiply these together. So 4I times 3 is just going to be 12I, but then over here, we have 4 times 6, that's 24, and then we have I times I, that's an I squared. And so that's where we come back to our definition of this imaginary unit of I squared equals -1. All right, and so when we go back over here, we have an I squared there. That means this becomes 12I, and so this I squared becomes -1, and then this becomes 12I plus 24, or if you wanted, you can write it in the, it doesn't really make that big a difference, but it would be 24 plus 12I for the A plus BI form. All right, and that's pretty much how you handle those. Otherwise, all your operations are the same. So it's almost like if you were doing 4x times 3 minus 6x, you'd end up with a 12x minus 24x squared, just like kind of what we had right there. You're just going to treat it pretty much just the same as that, except that anytime you get an I squared, you swap it out for a -1. All right, let's take a quick look at number 10 here, and we'll try this one. So here we're just going to do our regular old foiling. Again, we'll take this 10 and we'll multiply it through onto everything in the next set of parentheses there. So we have 10 times 4 plus 10 times -2I. And then we'll do the next part, which is the -6I, and we'll multiply it by the 4 and the -2I. And so we get a plus -6I times 4, and we get a plus -6I times -2I. And so now it's just a matter of going through and doing those, and maybe moving this over so I didn't run into the next problem like that. And so we get 10 times 4 is 40. We get 10 times -2 is -20. Carry the I along. -6 times 4 is -24, and then carry the I. And then over here, we have -6 times -2. That's a positive 12, and then we have our I squared. That I squared, of course, will become a -1. And so it's a matter of just grouping everything together. -20I and -24I is -44I. 12 times -1 is -12, -12. And so we end up with 40 minus 12, which is 28 minus 44I. And hopefully that is correct and that I didn't make any mistakes there. All right, and so for number 11, I'm going to let you do it mostly, but ultimately just rewrite it this way. 1 plus I times 1 plus I. And then do the same sort of thing that I just did on that previous one, multiplying term by term through, and you should be able to get it there. All right. On the next page, we are dividing now, where we have these going. And what we're going to do is our main goal, our goal here is to get rid, goal is no i's in the denominator. Okay, we want to get rid of them. And so the trick to do this is to multiply the top and bottom by what is called the complex conjugate. I know you've heard of conjugates probably before, but we want the complex conjugate. Pretty sure I spelled that right. Spelling is not my strong suit. And so what that is if we have an A plus BI, we're going to make it become A minus BI. And the reason we do this is because any complex number that you take and multiply by its own complex conjugate gives you a completely real number. all of the imaginary components will cancel out and they'll go away. So basically a plus bi times a minus bi is going to equal something totally real. Oops, totally real with no imaginary parts to it at all. So let me show you what I mean here. Let me zoom in on this one. Maybe I'll switch my color up here too. Let's go with this. Let's do, what we're going to do is multiply the top and bottom by 4 plus 5i. Because we had 4 minus 5i, so we're going to multiply it by 4 plus 5i over 4 plus 5i, like that. And so then what that does in the numerator is it just gives us 4 times 5, that's a 20. 5 times 5 is a 25i. Not writing it all out like I was before. Is a 25i. And then we have 4i times 4, that's 16i. And then 4 times 5 is 20. And then I times I is the I squared. And then in the denominator, we get 4 times 4 is 16. We get 4 times 5 is 20i. And then we get negative 5 times 4, that gives us minus 20i. So you see immediately those two will cancel. And then we get negative 5 times negative 5 is negative 25. And then we get the I times I and get an I squared. And so you see on the top, we just start doing what we did before. This becomes negative 1. So we have 20 minus 20. That's just by luck in this case, that those are going to end up canceling out. And then we have 25 plus 16, which would be 41i. And then in the denominator, we end up with just 16. And over here, we have this I squared becomes negative 1. So this becomes a plus 25. It becomes a 25 plus 16, which is also, again, 41. And so that's where we end up with is 41i over 41, which is just I. And so for that one, we ended up with just I. And so for the next one, if you were going to do this one, and I'll get you started on it, you would just multiply the top and bottom here by 2 minus 3i instead of that plus. You just basically make all the imaginary parts negative. 2 minus 3i. It's almost like squaring it into a totally real number, but you just make all the imaginary parts negative and then do the multiplication. So give that one a try, and then try also the ones following and see how they do for you. All right, so what we want to do here is actually worry about what happens when we're doing operations that involve square roots of negatives. And so the thing we've done before is perform the indicated operation and write the result in the sort. Recall that the square root of a negative number is undefined. So we have to turn this into I first. So what I can do here is I have this square root of negative 9. What I'm going to do is make this just like if I had square root of 8, I could make this into square root of 4 times 2, which I could make into the square root of 4, which I could make into the square root of 4 times the square root of 2. And then I could take the square root of 4 and say, oh, that's 2 times the square root of 2. Like, I can do that. Well, what I can do here with this is I can change this, and I can think of this as negative 1 times 9, like that. And then this becomes square root of negative 1 times square root of 9. And the square root of negative 1 is just I. And the square root of 9 is a 3. So this becomes 3i. For the 49, put my minus signs here, I've got square root of negative 1 times 49. And the square root of negative 1 times the square root of 49. And then I've got the square root of negative 1 is I. and the square root of 49 is 7. And so this ends up giving me 7i, like that. So it's 3i minus 7i, which is negative 4i. Okay, so you have to be very careful with that. And another place you need to be very careful of this is if you're doing multiplication of square roots. So for an example, if we had, let me separate this. If we had square root of negative 5 times the square root of negative 5 like that, and I'm going to do it two different ways. We'll have square root of negative 5 times square root of negative 5 like that. So if we do this, the first instinct might be to do this. Negative 5 times negative 5 like that. But then that becomes the square root of 25, which is just 5. However, that idea, that's incorrect. That's incorrect, okay? What you want to do is change this into, and I'm going to take a little shortcut. This is square root of negative 1 times 5. So it's just going to be I times the square root of 5 times I times the square root of 5. I mean, that's ultimately what we did. We just pulled that square root of negative 1 out and made it an I. So you end up with that, which gives you I squared times square root of 5 times square root of 5 is square root of 25, which is just, square root of 25, which is just going to be 5 times I squared. But I squared is negative 1, so it equals negative 5, not positive 5. This is the correct way, right? This is incorrect. So whenever you're doing these, right, you want to make sure that when you have a square root of negative number, you want to pull that I out of it first before you move on to doing whatever it is you're going to do. So I'm going to do one more quick example, which is number 16, to show this to you. And then I'm going to let you work on these and work on some of the practice problems. So 18, you don't have to go through this whole thing like I did before, where I made it square root of negative 1 times 18. I can just go ahead and I know this is going to be I times the square root of 18. And I know this one's going to be I times the square root of 32. Okay? So I can just go ahead and do that real quick. After that, I can start worrying about trying to break down my square roots so that I can actually combine these together. Because right now I can't combine these because the square root of 18 and the square root of 32, I can't just add or subtract them together. So I can change this to I times the square root of 9 times the square root of 2. Square root of 9 times square root of 2 is the square root of 18. And then over here, I can make this square root of 16 times square root of 2, just like that. And now, square root of 9 is 3, so I have 3i times the square root of 2. And over here, square root of 16 is just a 4. So I have 4i times the square root of 2. Now, since my radicals are the same, I can actually go ahead and combine them. I just have 3i and minus 4i, which is negative 1i times the square root of 2. All right, there is my correct answer. If you want to think about this a little differently, here, let me put this off to the side. What essentially is happening here is I'm factoring out that square root of 2. So I have 3i minus 4i, and then I've got the square root of 2 over here that I'm just carrying along. So I wasn't sure if that little step there in red would help you or not, but that's essentially it. So you have to make sure before you add or subtract numbers with radicals in them that they're the same radical. You can't just do square root of 18 minus square root of 32 and make it something like square root of negative 14. That doesn't work. You got to get the same radicals there, and then you can add the constants that go along. All right, so let's try number 27. What we need to do here is, again, first we need to make sure that we don't have any square roots of negative numbers, because again, those are undefined. So I'm going to rewrite this as I times the square root of 10, and this one as I times the square root of 2 plus the square root of 5. Now it's going to be just a matter of actually multiplying everything together. So I'll multiply the I times the square root of 10 times the I times the square root of 2. I times I will give me I squared. And then I'll get square root of 10 times square root of 2. And then I'll do that first I square root of 10 times the square root of 5. So I'll get a plus I square root of 10 times square root of 5. When we're multiplying radicals that don't have i's in them, we can go ahead and just combine them. So this becomes I squared times the square root of 20 plus I times the square root of 50, 5 times 10. And then this I squared, I should have done it, this I squared here actually is a -1, right? So what we end up with is negative square root of 20 plus square root of 50 times I. And so this is in our A plus BI form. Now I may want to reduce this a little further, because I noticed that my square root of 20, I can actually break that down, and I can make this, because I know it's divisible by 4, I can make this negative square root of 4 times square root of 5, like that. And this one I can do as square root of 2, or actually let me do square root of 25 times square root of 2, and then carry the I along. And so here, the square root of 4 is just a 2. So this is -2 root 5. And then over here, square root of 25 is just 5 root 2 I. And so that's probably most likely the answer form you'll see it in is like that. And that's our A plus BI form. And that's number 27. And so we'll check it there. And yeah, that looks good.